Great, we're here. Good evening. My name is Marcelo. I am an engineer at ANZ, and I'm here to talk to you tonight about Swift Registry and how it pertains to dependencies outside of GitHub. Thanks for coming. Well, to begin with, we're going to start by talking about this little tool that I built the other day called Swift Figlet. Let me jump to it. I got a couple. This is going to be a bit interactive. We're going to be talking about, we're going to be jumping to code and coming back to presentation. Okay? So this is Swift Figlet. If I run it,
Can you make that a bit bigger?
I sure do. There you go.
Thank you.
Is it good enough? Good. If I do run it, you will see that it's a very simple tool, and all it does, it emits an error. Oh, of course. Give me 1 second, because the demo gods are not always with me. There you go. I'll run this from the command line. So if I do run Swift Figlet, I'm going to do Swift run. There you go. It's just a small tool. That. Thank you.
Always for demos.
Yeah. Well, it's good to have a fallback. It's just a small tool that every time I run, it prints hello CocoaHeads on a different font. And look at that. Hello CocoaHeads. Right? Thank you. I put a lot of effort into this. It's a very simple tool. And just to show what it does, it uses this application called Figlet. That's a very old application that's been, maybe comes from, I don't know, BSD to whatever, from back in the day. It's been coming on Unix after Unix. It's a command line tool you can install with Brew. And with this, I just called this dependency called swell, which we're going to talk about briefly. I call swell with this command i2 that gets me a fonts directory. And then I call ls with this font directory, and I get a list of fonts that the application supports. I get a random font out of the list. And then I call Figlet again, specifying the font that was chosen randomly and saying hello CocoaHeads. Very simple application, right? So if I go back here, we have seen that Swift Figlet depends on swell. And if I come back here and show you what it looks like, it's a dependency here in our package.swift. Okay, so it's here, and actually a bit of marketing if you want to use it yourself, it's in GitHub. Anyway, what I wanted to talk about tonight is what if swell can't be on GitHub? What if swell is an enterprise tool that cannot be actually open source? What if you don't trust GitHub to change tags all the time and point to different versions every time somebody does, every time your package resolves the packages? What if you're shy and you don't want it online? Okay, so that's when the Swift registry comes in, right? And to show you how it works, and here I am. I think I started on a wrong foot with the demo gods, but let's keep strong. I believe they will heed me eventually. If I come here to my swell run locally, I'm going to do a little command here that, let me just write it because I cannot talk and.
Can you blow it up a bit, Marcelo?
Hmm?
Can you make it bigger?
Probably
Possibly.
can. Never tried this, but there you go. Okay, so I'm gonna do a Swift Package Registry. I'm going to do publish. I'm gonna publish swell into a package registry. I'm going to do help because I'm blanking out. And I'm gonna set a scope, Marcelo yes.swell, which is the package name. I'm gonna do a version. I'm going to do an URL. That's the URL where the registry is, which is going to be on HTTP localhost 8080, and I'm going to do a command that just came out with the beta of Swift 6. It's called Allow Insecure HTTP. And if I do that, please gods help me to do a dance. What do you want? There you go. It's successfully published. One more thing that I have to do. Hold on, we're not done yet. One more thing that I have to do is I'm going to go back to my Swift Figlet, was running the application. I'm going to do a Swift. I'm going to do, again, package registry. I'm going to do a set as a subcommand. And I'm going to do a help because my memory is not good enough for this. And then I'm going to do a HTTP localhost 8080. I'm going to set my scope as Marcelo. We're going to talk about scopes later. But if I do this, it's going to complain because I did not add the last argument, which is allow insecure HTTP. There you go. And what this did was it created a file for me here in swiftpm-configurations.registry.json that tells me that packages that belong to the scope marcelo.es are in this server here called localhost 8080. Okay? So now I'm going to go back to Xcode, which was giving me a hard time, and I'm going to come here to my package.swift. And instead of using the GitHub address for it, I'm going to point to an ID. I'm going to point to my scope and package name. And here on the dependency, I'm going to put solo.e-es.swell, which is the ID of the package. And now I'm going to close Xcode because it's going through a resolution and it's going to fail, obviously. But I'm going to try and open this again. Second is the charm, right? There you go. It actually resolved. Can you see it? Right. So you can see here this little icon here on the left. It's a little bit different from the icon that we had before. Right, it's got a little bit of an edge on the box here. But you can see that it has resolved. It's a dependency that it has downloaded. And if I get to run it, will it work?
Must be fake it works.
Ah, come on, mate. I'm going to do this from the command line again. Am I in the wrong one? Yeah, in the right one. So you can see here that's actually fetching Marcelo-S. Marcelo-S swell, which is different from the message that we saw before when it was fetching from GitHub, right? And I can keep on running it because it's just so visually appealing. I love this. Right, so coming back to our presentation, what sort of Witcher is this? Okay, well, it's actually a Swift Package Registry, right? It's a service specification that Apple released. Was it 3 years ago? It came with Xcode 14, so I think it would be...
5.7.
Yeah, Swift 5.7. It's a service specification. It basically defines 6 endpoints, and those are all the endpoints that Swift needs to resolve packages, right? And it goes ahead and it gives us a guidelines on how to use it, including how it is implemented in the Swift package, in the Swift command itself, the Swift package command itself, like we saw using Swift Package Registry, and how to use from that, right? But point is, it is just a specification. So where exactly did swell go? Where did I push the swell to? Why was I running localhost? And here's where I introduce Swift Birdhouse. Thank you. Now, Swift Birdhouse is a project that I worked on the weekend. ChatGPT helped me with the logo, as you can see. It's a really simple, for now, it's a really simple implementation of the Swift registry. It tries to be as pure to specs as possible. It's running Hummingbird 2, which is a new server that's just coming out. As actually, the version 2 is not even out. I'm using RC1. RC2 came out yesterday, actually. It aims to be as light as possible, aims to be as fast and light as possible in runtime. and it's not ready for production. So just be warned. But like, watch the space. Yet. So let's go back and see the log, see what happened when we actually resolved the package. When I come here to my, here, no, there. If I come back here and I come here, this is where Swift Package Registry is running. And I'll show you what happened. When I published the package initially, it sent a put request to the registry. And here are the logs, right? And it sent a push request to my scope, to my package name, and to this version, right? Later, a couple of minutes later, when I was building it through the command line because Xcode wouldn't help, it was resolved to, it first started by checking if I have it, what versions of Swell I have, and then it got some metadata about those versions. And then it downloaded the package of Swift for it, and it does that to check if the package has any other dependencies that it has to resolve as well. And then it weirdly goes back to the metadata for some reason, and I believe, and this is the internal implementation, I haven't gone that deep, but I believe it's to fetch the checksum of the packages of that version. And then it goes ahead and downloads the zip, which has the dependency itself. Okay? And if I go ahead on another step and I go here to this, it's going to be maybe too small, but this is, well, Rapid API, but it's just like Postman. It's just a client for accessing endpoint APIs, right? If it goes and it calls the first endpoint that we saw there, which is list package registries, releases, and if I run this, it's going to go through this endpoint here, Marcelo ES/swell, and it's going to return a list of releases that this package has published, this registry has published. If it goes here to fetch metadata, it's going to return a couple of stuff that's useful for the consumer to know, which would be the ID of that package for that specific version, and this checksum, which in this checksum, as a side note, it is saved locally, just so that if you download a package again, it goes to, it checks if the package hasn't changed the checksum or not. If you go here and download this, it's going to download the package.swift of the package, and then it's going to go and this final endpoint here is just going to download the source archive. Okay, we're going to talk about this other endpoint soon, and this one is the endpoint where we publish the package. That's it. That's 6 endpoints, and that covers the whole of Swift registry, and that's everything that we need for resolving packages. Cool. I was talking about scopes, right? So scopes gives us the ability, and scopes in this case was Marcelo-ES. I decided to use the same one in GitHub, but it does not necessarily need to be the same one that's reflected in GitHub. But scopes gives us the ability of defining where we're going to be looking for packages, right? Which registry is going to be looking for packages. So suppose in this case here that we have 2 IDs. One is byteme.pixels and the other one is nerdvana.glitch, right? And those are 2 scopes that we're reaching out. And if we see the registry configuration for the specific package, we're going to see that they're going to be pointing, byteme is going to be pointing to one registry in one website, whereas nerdvana is going to be pointing to another one, right? As a side note, there is a way, if we think that all the packages that we're going to be using are going to be in a specific endpoint, then we can just set as a default URL, and we're going to just say that just look for every single thing in this specific URL. Cool. But what happens, for example, and this is an interesting note that you will run into if you start digging this out. We're going to have a couple of packages that are going to be on registry, and we have a couple of packages that are going to be on GitHub. Let's say, for example, here. Is this big enough? Cool. We have byteme. We have a package that's called Gremlins that observes to, or that depends on byteme.pixels and depends on nerdvana.glitch, right? But then if we go and take a look at pixels, we're going to see that it also depends on nerdvana.glitch, but it depends on nerdvana.glitch in GitHub and not in the registry. So just to summarize, this is what we have. We have gremlins depending on Nirvana glitch, pixel, and then pixels depending on glitch from GitHub. So how does package.registry know that glitch and nirvana.glitch are the same package? And it doesn't naturally, but it does use an endpoint. It can, and that's where this last endpoint that I mentioned was talking about. There's this last endpoint that's called lookup packages identifiers by URL, and if you run it, you're going to provide an URL, which in this case here is github.com/marcelo.farewell, and that's going to give me the identifier that that registry has for that specific URL, which means that every package that's registered has the option of actually having an URL associated with it. So when Swift Package Registry, when the client goes to Swift Package Registry and asks if this URL is in the registry is going to return the identifier of the package, and that way Swift can disambiguate if two packages are the same. But coming from that, there is still one more thing. We have three ways of actually deciding what to do with that, right? So there are three options that come with Swift Build. One, and the one that's disabled, enabled by default, is to disable SCM-to-registry transformation. And what it does is that it just lets it conflict. It does not try and check if things are the same. But the other two are interesting. The second one here, use registry identity for SCM, is about using the registry to find if two or more of the dependencies are the same, but then use the version in the registry. And the last one here is replace SCM with registry. Is the same, but instead of using the version that is in the source control manager in GitHub, it uses the registry version. And with that, we covered a very good chunk of what the Swift Package Registry is. And if you have any questions, fire up.
Just a reminder for those watching on live stream, please feel free to ask questions either in the chat on YouTube or in Slack in the Melbourne Meetup channel. Does anybody in the room have questions?
Hey Marcelo, some of the JSON responses were escaped for things like URL and stuff like that. How important is that?
From what I observed, it's going to be a Swift implementation that's going to be parsing that. So everything there is dealt by Swift itself, which is usually very flexible with that. So unless you're dealing with some kind of third-party framework that has to go and retrieve packages for some, maybe an enterprise reason that wants to maybe check which packages there are in the enterprise registry, we're fine. Yeah?
What do you see as like the most common use case for something like this?
Well, the first use case that comes to your head is enterprise, right? You don't want to publish your dependencies, and because of the way that Swift Package Manager limits the dependencies these days, you see people going outside of the way to try and build like sub-Git repositories, or like making weird build time scripts that copy things in and make sure the dependencies are in on build time. This fixes that. This brings it to Apple's responsibility to make sure that the system works. But it's something, the strong use case is that really GitHub tags, it's not really designed for the use case that we're using here right now. We're using that tags to define versions, which is fine, but if you depend on something and the author of that changes the tag into another commit, apart from the checksum of that commit that was there before in your build system, you have no ways of trusting the system that you're going to be getting what you want. So you can think of like a lot some repositories on GitHub if they could be given access to an infiltrator, they could go and change tags into like commits that could have some dodgy coding. So this by standard guarantees that the checksums keep the same. So yeah.
I have a question, Marcelo.
Yeah.
What's the biggest gotcha you found in your exploration with Swift registries and the support that's in Swift PM?
It's Xcode. I mean, I hate that I keep on bringing this back, but it's relatively transparent with Swift itself as a tool, and Swift Package Manager you can open it. If you have something that you do not really understand, you can go in the commit history of Swift Package Manager and figure out why decisions were made. You can see descriptions, and it's pretty open with Swift evolution. You can find the rationale behind decisions. When you bring that to an Xcode project, pretty much everything that we have seen is implemented in Xcode as well to a certain level, but there's zero documentation available. So you might end up, if you trying to bring this up to a bigger project, either you slice your project down into smaller packages, Swift packages, that you can distribute and observe, or you could try to find the hidden build variables in Xcode that allow you to specify that you can choose the registry version of a package instead of the GitHub version. So
none of that's documented. No, not surprised.
Yeah, it's sad.
Any other questions in the room for Marcelo?
It's quicker, yeah. Like there's a performance benefit of using it too. Is that or no?
It's 5 commands. Is it quicker than
downloading from GitHub?
Is it quicker than GitHub? If you compare, if all things considered, if you consider GitHub is on the same speed as your local server that would be distributing the registries for in your internal network, it will be equivalent, to say the best. But considering Swift Package Registry would be run locally in your corporate network, it can be quicker.
I think there's a lot less overhead too, right? Because normally you need to clone the repo, and if the repo is big, you're downloading all of the history to come with that, and then checking out the tag, passing the package to Swift,
that's a good point.
Instead of just hitting an API and grabbing it.
That's a very good point. If I may do an unscripted exploration here, if I go back here to Swift Figlet and I go to my .build folder, I'm gonna see that there are like checkouts, actually repositories. You can see that there was a clone here of the Swift argument parser, right? And as well when I had it observed from GitHub. And then I go down to checkouts. It's actually the clone is going to be here. That the repository is going to be the specific checkout. Well, and then if I go to my registry, the registry folder, you're going to see download, scope, swell. It's just going to be the package the way that it was downloaded. So there was no, sometimes you're depending on a repo that is 300 megabytes big, if you go for Lotte, for example. With this, you would be downloading only a specific checkout, so you don't need to download the whole GitHub dependency. Swift does optimize it by not downloading the whole history, but still, this is just a release. So, and this is designed for purpose, right? Git was designed for so many things. This is designed for dependencies. So there are advantages to that. Oh, please.
Thanks, Marcelo, for the talk. My question is again about use case. So you mentioned about this is for more towards enterprise requirements for stability and security, right? But I wonder if you have so many dependencies, would you end up making all those dependencies locally maintained And if so, like pulling into this registry, if so, how do you resolve like more future update on the original forked repo, and then like there's potentially a lot to maintain by yourself. Is that the case?
You might be thinking about publishing public repositories into a specific internal registry. Is that?
Yeah, my understanding was like you get the swell to the local maintained registry. Would you get to the point where you are doing a lot for all the dependencies you have?
Look, you could if you have a restriction on going online. For example, if you are in a network that blocks GitHub access for build system, for example, you might end up having to maintain something that publishes to internal repo. But I think that's one use case, and we're coming back to the enterprise use case. But there are there could be use cases where you don't even publish to GitHub, right? So you have your internal libraries that are in your internal repositories. They're not published to GitHub, and you push them to a registry somewhere. In which case, you would have possibly a CI system that observes on changes to main or to a specific release branch and pushes to a registry, and with incremental versioning. So is there an overhead? I'm not going to deny it. Yeah, there is going to be an overhead, but it's a minimal overhead that you need to satisfy certain criteria, which would be not making something public and not distributing it over Git.
Yeah, thanks. Just one minor follow-up. How do you keep the dependencies synchronized to the original one, like more security updates, fixes, etc.?
I think keeping dependencies synchronized is a choice, right?
Yeah.
From haven't explored that, but if I would do it, there would probably be some sort of hook in GitHub that sends you requests when a new release is done from a specific software. You can hook into that and spawn a local CI check that builds your system and publishes to a local Swift registry.
Thank you.
I think that would be my approach. Thanks for the question.
We got time.
Just a quick question about developer experience. How do you find prompt and rapid API? Like, what the advantages over terminal and Postman, for example?
Sorry,
You've lost your
you
screen
mean
there.
prompt?
Just bring my blank.
That's why my face was so big. Did you mean prompt?
Prompt, yeah, like why do you use that over terminal?
This one?
What's that?
Yeah, I'm a bit of a terminal geek. I mean, and at the same, it's the contradiction of my life, because I'm a really big terminal geek, and I am also a very big fan of native experiences. And prompt kind of gives me this middle ground. It's by they call Coda? Panic. Panic, that's right. It's by Panic. It's an app that has been for iOS since forever, really, and they just released the Mac version a couple of months ago. It's really fast. It's fully true caller support. So if you're looking to something to play with as a terminal, I recommend it.
And Rapid API is the other one?
Yeah, it's the same thing. It's more about having a native application. And I played with Postman for a while. There's also Insomnia. I think Prompt is Rapid API, it was Paul until a couple months ago, or a year ago. It became Rapid API, but I think it's not as feature-rich as the other ones, but
I've used Paul for years, can strongly recommend it.
yeah.
Yep.
Cool. Anything else?
Thanks very much.
Thanks for having me.